Hey guys, I'm gonna try something here, and you might have to bear with me a little bit as far as the camera work goes, but we're gonna try to walk through this day 3 lesson with the quadratic formula because y'all haven't really been exposed to this yet, and this is something important that you're gonna need to know. This lesson starts on page 637 in your book. And I also have the day 3 assignment pulled up on the computer, which basically all this is the slides. The day 3 assignment, it links you to the slides that you can access anytime anyways. So the first slide, we have a quadratic equation here, and it wants you to solve it in your book by factoring and graphing and completing the square, which I'm just gonna show you what they put on the screen here. The easiest way to do this one is gonna be factoring. We are looking for a number that multiplies to give us 6 and then adds up to give us 5. That's 2 and 3, and we factor it out there. If you were to convert this to the vertex form so you can graph it, you would get this. You would notice that the parabola touches the x-axis at -2 and at -3. So same result. And then the last way would be completing the square. And this is probably the way I would not want to do this one because it does get a little messy there. The quadratic formula is going to be a fourth way to solve some of these. Sometimes you're going to run into some that don't really work out. They give us another one on page 2. If we were to try to factor this, we would have to multiply 2 times -3, and that would give us -6. We would factor -6, and then you're looking for 2 factors that would add up to be that middle number of 3. Well, this one would give us 5. This would give us 1. This would give us -5 and -1. So none would work factoring. So this would not be a very good equation to use the factoring method on. If you were to try to solve it by graphing, well, if you were to convert to vertex form and graph, you're never going to get the answer to this. Now, if you have Desmos or if you have a graphing calculator, you could do this and you could get the answer this way. But without that technology, you would never get those 2 answers. And then the third form, completing the square. Completing the square will work, but it gets pretty messy there. Like there's a lot there that you're not going to want to do by hand. So whenever none of these 3 methods work out easily, this is when you're going to want to use the quadratic equation. Page 3 is what introduces you to this quadratic formula. And to be honest with you, you're never going to need to know how this is derived. Like, they want you to sit here and click through these and figure out how to come up with the formula, and it gets pretty messy also. You're not going to need that, to be honest with you. So if I were you, I would skip straight to the 8th slide in the page, and here is your formula. I'm on page 639 now in the book. Your formula is x equals -b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. It seems like a lot, seems like something that's going to be difficult. It's really not that bad though. So I'll give you a second here to get that copy down. This is going to be something you're going to have to memorize for the next couple years, and you're going to need to know how to use this, which is why I wanted to go ahead and go over this with you. I'm going to skip ahead a couple pages on the slides. Now I'm on slide 5 and page 640 in your book. It says to apply the quadratic formula to solve this equation. And this is where you might have to kind of bear with me on the camera work. Page 5 does follow along with this exact same problem. I'm just going to kind of work through it with you here. Whenever you are going to plug in, it's very repetitive. It's the same thing every time. Your A term is always going to be the squared term. B is always going to be the middle term. C is always going to be that constant at the end. So all we're going to do is we're going to plug those three numbers into the formula. Anywhere you see an A, you're going to put a 2. There's an A here and an A here. So actually here, I'm going to do this. I'm going to start with B here. That way I can go in order. So B is 3. So I'm going to put a 3 where the B was. So I'm going to have negative 3 plus or minus the square root of, okay, we have another B. So I'm going to put 3 again. 3 squared minus 4 times A. All right, there's an A. So I'm going to put 2 for A. And then C. So I'm going to put negative 3 for C. And then this is all divided by 2 times A. So 2, and then A is also 2, so 2 times 2. So now it's plugged in, and we're just going to start solving. You're going to start with that exponent, so we have 3 squared. So 3 times 3 is 9. Okay, then we have all of these numbers being multiplied. So negative 4 times 2 is negative 8. Times negative 3, negative 8 times negative 3 is positive 24. And then on the bottom, 2 times 2 is 4. Combine the two that are under the radical, so 9 plus 24 is going to be 33. So we have negative 3 plus or minus the square root of 33 divided by 4. And I'm going to kind of work through it here on the screen, show you what they do on the slides. The first step they do is to make that a negative 3. Then they square the 3 and get 9. Now, they actually don't multiply negative 4. They multiply just 4, and they leave that negative. And then on the next step, they say 2 negatives make a big positive there. But I like to go ahead and multiply that negative. Either way, it's going to work out the same way. So they get to the same point that we have. And then you're going to have 2 different, let me pause here. You're going to have 2 different answers because you're going to cross the axis twice. Think about if you were graphing this parabola. If you're graphing this parabola, let's just say it goes something like this, and I'm just making an example. There's 2 answers because it crosses the x-axis twice. Well, you're going to have 2 different answers on this because one of them is going to be negative 3 plus square root of 33 divided by 4. The other one is going to be negative 3 minus square root of 33 divided by 4. And that's what they did here. One answer has the plus, one answer has the minus. And then on this one, because there is no square root of 33, you're going to get a big long decimal. And it's not going to come out evenly. So they went ahead and stopped there. If you were to take a calculator and solve that out, you could say negative 3 plus the square root of 33. I'm going to go ahead and press equals there. And then divide by 4. You get 0.6861, big old long string of numbers. Well, if I go back to the previous slide, where I believe they worked that out for us. Come on. When they worked it out, they got the same thing on the quadratic or on the completing the square method, just without all this messiness here. And they also got the same thing on the graphing one. Let me go back ahead. All right, so what if we did the one where it was the minus instead? So I'm going to clear my calculator. We're going to have -3. This time it's going to be minus the square root of 33. Go ahead and press equals. And then divide that by 4. And you get -2.186 whatever. And if we go back to where they had worked this out for us, -2.186, or if they went through the completing the square method, -2.186, just much less messy to do it this way. And you know, on the ones that work out to be whole numbers, it'll work like this as well, but you would have a perfect square root here. So if this was like the square root of 25, well, you would say the square root of 25 is 5. So -3 plus 5 divided by 4, or -3 minus 5 divided by 4. And then you would get a whole number answer. But it did not work out this way on this one. So back to our assignment, back to our slides. Oh, well, there was our answers right there. Same thing that they had previously. They give you another example here. So I'm going to work through one more with you. We're going to use that exact same formula every single time. -b plus or minus the square root of b squared minus 4ac, all divided by 2a. Once again, the squared term is going to be a, the x term is going to be b, and the constant is going to be c. Remember that this -x, remember that that is a -1x, so we're going to plug in -1 for b. Once again, I'm going to start with the b term because that's what comes first on my equation here. So I have -b. So I'm going to have -1. -1 is my b, and it's already negative. So we know right here we're going to have two little negatives going to make a positive. So really this is going to end up being a +1, but I'm going to leave it like that for now. Plus or minus the square root of, all right, b squared, so -1 squared, minus 4 times a, okay, a on this one is 3, and c on this one is -5, all divided by 2a, and a is 3. All right, so to start solving through, first thing I'm going to do, the two little negatives over here, -1, that's really going to make a +1. -1 squared, so -1 times -1 is going to be a +1. -4 times -3 is -12. And then -12 times -5, that's going to be a +60. And then on the bottom, 2 times 3 is 6. Combine 60 plus 1 and get 61. So we're going to have two answers. We're going to have 1 plus square root of 61 divided by 6 and 1 minus square root of 61 divided by 6. Now, because 61 is an irrational number, it does not have a perfect square root. It's going to be one of these big long decimals. So what I would want to do is just come to my calculator now. 1 plus the square root of 61. By the way, on this calculator, the square root button is right over here. You have to press second and then the x squared. Press my equals and then divide by 6, and I get 1.468 whatever. And then on the other one, do the same thing, but this time it's going to be minus. So 1 minus the square root of 61 divided by 6, and get -1.135 whatever. Big old long string of numbers that we're not going to deal with. Now, they did get the same thing when they solved through here. They just did not solve it out all the way yet. Let's click to the next page and see if they did that for us on the next page. And it looks like they did not, but that should be right. And you can always go to Desmos and plug this in and see where it crosses the x-axis and kind of check yourself that way. There's another example here on number 9. I would strongly suggest that you guys take a look at that yourself, and then you can always use page 8 on the slides here to check yourself. There are 4 more. It gets to talking about what are imaginary numbers, what is the discriminant, so on and so forth. The rest of the slides will walk you through this. I really just wanted to make a video to show you how to use the quadratic formula. Whenever you get to the reinforcing, there are some more kind of practice equations for you. I really would suggest to take a few minutes, next page 22, there's some more. Take a few minutes at some point this week and work through those and just see how it goes for you. Shoot me a message if you get stuck and you need some help on it. More than willing to do that. But like I said at the beginning of the video, this is a skill that you are going to use over the next couple of years, and you really need to know how to do this. So take a few minutes and give it a try. I will talk to y'all later.